Hi there, I'm just going to take you through the physics equations needed for paper 2. So the first one we're going to use, this is a simple one, it's from maths, is speed is equal to distance divided by time. Okay, so we've got speed, the units are meters per second, distance in meters, time in seconds, and we can put it into a triangle like this. So speed equals distance equals speed times by time. Okay, because it's on the top in the equation, so it's got to be on the top here. So distance, meters, time, seconds, speed, meters per second. Next one. Acceleration is equal to change in velocity is equal to change in velocity divided by time taken. So the example for this would be going from 10 meters per second up to 30 meters per second. So the change is, so that they sometimes write it like this, change in velocity is equal to 20 meters per second. So that's how you work out the change. And we can put this into a triangle. So it's on the top in the equation, so change in velocity, they sometimes write it like this, that little triangle means change in velocity is acceleration times by time. And the units, so people always get the units wrong for acceleration. Remember, it's worth 1 mark in the exam. Meters per second squared. Equation for, so the units for velocity is meters per second. And again, time is in seconds. Right, next equation will be weight equals mass times gravity. Equals mass times by gravity, or gravitational field strength. So weight, remember this is a vector because it's a force which acts downwards, and mass is a scalar quantity. So weight's measured in newtons because it's a force, mass is kilograms, and gravity is newtons per kilogram. So on Earth, G is equal to 9.8 newtons per kilogram. So whatever mass is on Earth, we need to times it by 9.8. So my mass is about 70 kilograms. Times by 9.8 newtons per kilogram. I'll just grab my calculator so we can actually get an answer out. So 70 times by 9.8 is equal to 686 newtons. And putting it into a triangle, we have weight is mass times gravity. And we can work out the units for gravity because it's weight divided by mass, and that's newtons per kilogram. So if you can't remember the units, you can actually work them out using the equation. Right, next one. Now this is to do with a spring. So this is the force is equal to the spring constant times by the extension. Now this is all to do with a practical where you stretch a spring. So you have a spring and then you put a weight on it. So hang a mass on it, or put a force on it, and it stretches. And so it stretches by that amount. So that is the extension E. And the K, this thing here, so F is equal to KE. The K is the stiffness of the spring. So K is equal to the spring stiffness. So the harder it is to stretch a spring, the stiffer the spring is, the bigger the number. And so we've got units, so force again in newtons, And swing constant is newtons per metre. And extension is in metres. So you might have to convert centimetres into metres for this. So 100 centimetres is equal to 1 metre. So that's up to you. You should be able to work that out. So remember, it's got to be in metres. So put it into a triangle. I'm going to use the symbols for this. F equals K times E. There we go. Right, next one. Force equals mass times acceleration. This is Newton's second law. Force is equal to mass times by acceleration. Or F equals ma. Now we can put it into a triangle here. So F equals m times a. So force measured in newtons, we know that. Mass, kilograms. And acceleration, meters per second squared. So an example would be if a car of, well, they quite often do it so they work out the acceleration. Acceleration, that's that there, is equal to force divided by mass. And so if you had a force of 10,000 newtons on a car of 1,500 kilograms, you do that on your calculator. So 10,000 divided by 1,500 is equal to 6.6666 recurring. So you would have to put this into 3 significant figures, so 6.67. And that's the units for acceleration again, meters per second squared. So remember, you might need to remember this equation, so 1 mark, do the sum, work out the answer, put it into significant figures and give the units. So sometimes there's lots of marks available for a question like this. Now we've got an equation for momentum. Momentum is equal to mass times velocity. Velocity. So we've got a triangle. Again, it doesn't matter. You don't need to know the symbols for these. So I'm just going to call it mum equals mass times velocity. And we've got some momentum. Is because we're timesing mass and velocity, that's kilogram and that's meters per second. We just times them in to get the unit. So kilogram, meters per second. Velocity, meters per second. And mass is kilograms. And so this could be a rhino. Oh no, I've got to draw a rhino now. There we go. A rhino. It's actually not too bad. Little ears. Which is 800 kilograms. Moving at 5 meters per second. So the momentum equals mass times velocity is equal to 5 times 800. So 5 times 800 is equal to 4,000. And we've got kilogram meters per second. It's not kilogram per meters per second, it's kilogram meters per second. Next one is, now these are equations to do with waves and the electromagnetic spectrum. So we've got this equation, wave speed is equal to frequency times by wavelength. So we've got wave speed meters per second, frequency is in hertz, and wavelength is in meters. And so this is talking about waves, and so we're looking at a wave here. So we'll just quickly go over this. And so one wave length is from there to there, or from this point to this point. So from one point on one wave to the same point on the next wave. So that's the wavelength. Now the frequency, so I'll just write this over here. So frequency is number of waves passing a point in 1 second. Or it can be written as the number of vibrations in 1 second, but this would get us. So we've got the wave speed, and they quite often use this with electromagnetic radiation, so you need to be able to do standard form. So for instance, a million would be written as 1 times 10 to the 6. Okay, if that was the speed, that would be meters per second, but speed of light is 300 million. You need meters per second. You need to be able to write that on your calculator and do sums like this. So with 3 times 10 to the 8, so that's using the button on your calculator. And so rearranging it, we've got wave speed. So wave speed is frequency times wavelength. And so the symbols for this are quite easy to remember. So V equals F times lambda, which is like an upside down Y, so you can write it like that. V equals F times lambda. Okay, just knowing the equations gets you most of the way through this exam. Right, we've got another equation which is given to you, but it's worth remembering. So the T is equal to 1 over frequency. So this is the time period, which is the time for one wave. So how long the time it takes for one wave to pass you is equal to 1 divided by the frequency. So this is given, but it's easy to remember. And then you can work out the frequency. So you might need to be able to rearrange it as 1 divided by the time period. So frequency is in hertz, and time period, because it's time, it's in seconds. And so if we know what the time for one wave is, we can work out how many waves in 1 second. If we know what the frequency is, we can know how long it takes one wave to go past you. And the last equation is F equals BIL. Now this is to do with, now I'm going to try and draw some magnets, north and south. So if you've got a wire, let's change colours a minute for wire. Got a wire in a magnetic field with a current going through it. Now the length of the wire is in the magnetic field is going to be that length there. So that is L. Okay, and we've got a current I travelling through this wire. So this is a wire going through a magnetic field with a current travelling through it. And the important thing is the length of the wire. So we've got the length. B is the magnetic field. B is the magnetic field strength. Magnetic field strength. So that's measured in Teslas, or T. It's usually a really small number, so it's not sometimes milliteslas. So if you're given a number, so 3 milliteslas, on the calculator you've got to do 3 times 10 to the minus 3, because it's a small number. Okay, and L is measured in meters, and I is measured in amps. Force is obviously measured in newtons, and so you could work out what force is needed if you've got 3 times 10 to the minus 3 Tesla magnetic field strength times by a 2 amp current times by, now sometimes this might be 5 centimeters, so you need to be able to convert that into meters, which is 0.05 meters. So this is a little bit harder, these sort of questions, and so we would do this on a calculator. 3 times 10 to the minus 3 times by 2 times by 0.05 is equal to, now it gives a standard form answer which you can write down, 3 times 10 to the minus 4, and remember that's in newtons. Right, that's 15 minutes to go through the equations, so you can play this video again and again. Hopefully I haven't made any mistakes, but next one I'm going to do the units.